Hello students, in this video I would like to discuss introduction of binomial theorem. This is very important topic for Iit Jee mains and advanced as well as CBSE board and state board exams. So let us start our video. In this chapter mainly we have three parts. Number one is binomial theorem for integral index. And second part is properties of binomial coefficients. And third part is binomial theorem for rational index. Today in this video, I would like to discuss binomial theorem for integral index. We are introducing binomial theorem for integral index. This is the first part, factorial. Product of consecutive 5 natural numbers can be written as 5 factorial. This also can be written as up to 4. We can write 4 factorial into 5. So next, product of first n natural numbers is denoted by n factorial, and also up to n minus 1. Up to n minus 1 is n minus 1 factorial into n. Up to n minus 1 can be written as n minus 1 factorial into n. Next, 0 factorial is 1. Formulae, we have NCR equals to, one of the formula is there, NCR equals to n factorial by n minus r factorial into r factorial. So using this formula, for example, 7C2 required. How to find 7C2? 7C2 is equals to 7 factorial by 7 minus 2 factorial into 2 factorial. This equals to 7 factorial by 7 minus 2 factorial is 5 factorial into 2 factorial. Now this numerator 7 factorial can be written as 7 into 6 into remaining 5 factorial. Actually 7 factorial means 1 to 7, product of 7 natural numbers. But I am writing only up to 5, 7, 6. Remaining 5 factorial divided by 5 factorial into 2 factorial. Now 5 factorial gets cancelled. 7 into 6 by 2 into 1. This equals to 21. Therefore, 7C2 value is how much? 21. I'm taking another example. 6C3. How to find 6C3 using the formula NCR. 6C3 equals to, about this form, substitute here, 6 factorial by 6 minus 3 factorial into 3 factorial. That implies 6 factorial by 6 minus 3 factorial equals to 3 factorial into 3 factorial. Numerator 6 factorial can be written as 6 into 5 into 4 into remaining I am writing 3 factorial. Actually 6 to 1 you should write. So remaining here denominator 3 factorial into 3 factorial. Now 3 factorial gets cancelled. So 6 into 5 into 4 by 3 into 2 into 1. So 3 2s are 6, 6 gets cancelled. So answer is 20. Therefore, the value of 6C3 equals to 20. So this is very important formula you have to learn. Next, we have to discuss NC0 and equals to NCN equals to 1. Both values. Substitute in the previous formula. First we are finding NC0. NC0 equals to formula n, substitute in this formula, n factorial by n minus 0 factorial into 0 factorial. Now that equals to n factorial by n minus 0 is n factorial into 0 factorial is 1. Now n factorial gets cancelled. Answer is 1. NC0 value is 1. Next, NCN. NCN, again substitute in this NCR formula. NCN equals to n factorial by n minus n factorial into n factorial. R is here, n again. Now, n factorial by n minus n, 0 factorial into n factorial. N factorial gets cancelled. 1 by 0 factorial is 1, that equals to 1. So finally, NC0 and NCN equals to 1. The next formula is NC1 equals to N. See, NC1 equals to N. The proof is same again. NC1 equals to N. See, I'll substitute here R equals to 1. NC1 value I am finding n factorial by n minus 1 factorial into 1 factorial. That implies this numerator n factorial can be written as n minus 1 factorial into n. So consecutive n natural numbers is n factorial. Previous number for n is n minus 1. So up to n minus 1 we can write n minus 1 factorial divided by again n minus 1 factorial into 1 factorial is 1. Now n minus 1 factorial gets cancelled. Answer is n. So NC1 value is n. This implies NC1 is n means we can write easily using this formula. If you want 5C1 directly we can write 5. 10C1 is equals to 10. The next formula is NCR equals to NCN minus R. I have to prove this. I am taking RHS part. RHS equals to what is this? NCN minus R. We are going to prove this form. Okay. So now once again apply NCR formula here. N factorial by n minus r. R means here n minus r. So n minus r factorial into r factorial means here n minus r factorial. Once again NCR. NCR can be written as n factorial by n minus r factorial into r factorial. Now n gets cancelled here. That implies n factorial by minus minus plus, that is r factorial into n minus r factorial. Clearly what is this? N factorial by n minus r factorial into r factorial can be written as NCR. So this is LHS. Okay. So NCR equals to what? NCN minus r. What is the use of this formula? For example, if you want to write 7C2, 7C2 also can express as 7C7 minus 2. NCR equals to NC and minus R. Therefore, 7C2 equals to 7C5. So both values are equal. 7C2 value and 7C5 value always equal. Why? This is the cause. NCR equals to NC and minus R. Now we have to discuss another formula. NCR plus NCR minus 1 equals to N plus 1 CR. For example, find 21C3 plus 21C2 equals to. This is in the form of NCR plus NCR minus 1. Here R is 3, 3 minus 1, 2. Therefore, with the help of this formula, this will be equals to N plus 1 CR. So 21C3 plus 21C2 equals to N plus 1 CR. What is N here? 21. 21 plus 1 CR. R means here 3. So therefore answer is 22C3. Let us start our actual topic. Why binomial theorem? Actually, binomial means The expression consisting two distinct terms. You know monomial, which consists only one term. Trinomial means the expression consisting three distinct terms. Why binomial theorem? What is the use of binomial theorem? I am going to give explanation for this question. You know binomial expansions, our well-known binomial expansions means a plus b whole square, a plus b whole cube. You know all formulas already. My question is why binomial theorem? See, observe the expansions left hand side. A plus b whole power 0 is 1, a plus b whole power 1 is a plus b. Next, a plus b whole square equals to a square plus 2ab plus b square. And third one, a plus b whole cube equals to a cube plus 3a square b plus 3ab square plus b cube. If you observe that all these in this side, all left hand side values all are binomials. Why? Which consist two distinct terms a plus b, a plus b, a plus b. Powers are given in that they are called index. The first line, if you observe that the index is 0. In the second line, index is 1. In the third line, a plus b whole square, the 2 is known as index here. And last fourth line, a plus b whole cube, the 3 is known as index. If you observe the right hand side expansions, they are called all are binomial expansions. If you want to write, for example, a plus b whole power 4, directly we can't write. Actually, how to find a plus b whole power 4? By multiplying with a plus b whole square into a plus b whole square. Will take lot of time. For example, if you want to find out a plus b whole power 5, a plus b whole power 6, if you want to write a plus b whole power 10, directly we can't expand them. When index is increasing, expansion will be difficult. So to solve such type of problems, they introduce one of the theorem that is known as binomial theorem, which is useful to expand binomial terms. Whatever the index, the theorem is useful to expand binomial terms. So this theorem is known as binomial theorem. See, in RHS side, a plus b whole power 1 expansion here RHS we are getting two terms. A plus b whole square containing number of terms are 3. A plus b whole cube containing 4 terms. And next, what are the coefficients here? The coefficient of A is here. Observe this. Index is, when index is 1, then index is 1. What are the coefficients here? Coefficient of A is 1. Coefficient of B is 1. When index is 2, write the coefficients. Coefficient of A square is 1. Coefficient of AB is 2. Coefficient of B square is 1. When index is 0, here this is only constant is there. When index is 3, what are the coefficients here? Coefficient of A cube is 1. Coefficient of A square B is 3. Coefficient of AB square is 3. Coefficient of B cube is 1. If you observe, this is one of the triangle here. This is one of the shape of the triangle. See, we can find coefficient using this triangle also. If you join 1 plus 1, 1 plus 1 will be 2. This is the coefficient of a plus b whole square, one of the coefficient. And if you add 1 and 2, this will be 3. 2 plus 1 will be 3. And also, first and last always fixed. First and last coefficients are always 1. So with respect to, with the help of this triangle, we can write the expansion of a plus b whole power 4 also. I want to write expansion of a plus b whole power 4. Now, always here these are fixed. First and last numbers are fixed. Next coefficient is here 1 plus 3. How much? 1 plus 3 will be 4. Next coefficient is 3 plus 3. This is 6. And then the next coefficient is 3 plus 1, 4. And first and last always same. Using these coefficients, we can write a plus b whole power 4 also. So this is a power 4. And next plus second coefficient is 4. So 4 into a cube b. And next coefficient 6. 6 into a square b square. And plus b into here 4 into next this is a b cube, and the last one is b power 4. Coefficient of b power 4 is 1. So with the help of this triangle we can write a plus b whole power 4, and the same way we can express a plus b whole power 5 also. If you observe the pattern here, powers of a are decreasing here. For here 3, 2, cm 1 and 0. Powers of b are increasing. According to that I am writing same pattern we are following in the expansion of a plus b whole power 4. But we are finding the coefficient from this triangle. This triangle is known as Pascal's triangle. With the help of Pascal's triangle, we can find coefficients of any index. When index is, if you want to write expansion a plus b whole power 5, if you extend this triangle, you will get the coefficients again. But this process also will be difficult. Why? We can't form the triangle like this. In this way, this will be very difficult. For example, if you want to express a plus b whole power 50, the triangle, drawing the triangle will be very difficult. So that's why one of the theorem is introduced, which is useful to expand binomial terms for some indexes. This theorem is known as binomial theorem. You all know how to expand a plus b whole power 1, a plus b whole square, a plus b whole cube. Indirectly, all these right hand side expansions are follows properties of binomial theorem. That's why we know indirectly binomial theorem, because I will explain for that. See, a plus b whole power 1 equals to a plus b. This can be written as, also can be written as a plus b, also can be written as coefficient of a is 1, that also with respect to index you can write in this model 1c0 into a. 1c0 will be 1 plus b coefficient is 1. This can be written as 1c1 into b. 1c1 is also 1. Both finally this equals to a plus b. Similarly, a square plus b square can express as, with the help of index 2, a square coefficient is 1 here. So this can be written as, in terms of 2 you should write 2c0 into a square. Next 2 can be written as 2c1 into ab, and b square coefficient is again 1. This can be written as, in terms of 2, 2c2b square. Similarly, a plus b whole cube. Here index is 3. With the help of 3, this line also can be written as 3c0 a cube plus 3c1 into a square b plus 3c2 into ab square plus 3c3 into b cube. Now, a plus b whole power 4, here index is 4, we can write these are 4c0 into a power 4 with the help of 4c0 to 4c4. Here 3c0 to 3c3, 2c0 to 2c2, 1c0 to 1c1. So next plus 4 can be written as, here 4c1 value is 4, so a cube b. Next plus 4c2 is nothing but 6. This 6 can be written as 4c2 into ab square, a square, b square. Next plus this 4 can be written as 4c3 into AB cube. Last 1 is there here, 1 can be written as 4c4 into b power 4. So if you observe this, these are all known as binomial expansions. These all 4 expansions follows properties of binomial theorem. That's why indirectly we know binomial theorem without knowing the theorem, but we are writing always binomial theorem. When you write a plus b whole square means a square plus 2ab plus b square means indirectly you are writing like this 2c0 a square plus 2c1 ab plus 2c2 b square. This is called binomial theorem. Using binomial theorem we are expanding a plus b whole square. With the help of this pattern, index is 1, we are writing 1, 1. Index is 2, 2, 2. Index is 3, 3c0 to 3c3. When index is 4, 4c0 to 4c4 last. And also, if you observe that all terms here, index of each term is nothing but equals to 4. See, indices, sum of the indices of each term will be equals to given index. 3 plus 1, 4. 2 plus 2, 4. 1 plus 3, 4. Here, 4. Similarly, in the index 3 case also, index 3. See here, 2 plus 1 will be 3. 1 plus 2, 3, 3. Similarly, in this case also. And also here, if you observe that, this index is 1, but number of terms is 2. Now, if index is 2, number of terms total 1, 2, 3. First term, second term, this is third term. When index is 3, we will have total number of terms are 4. When index is 4, number of terms containing here 5 terms. Whatever the index is given, we can expand. A plus b, for example, if you want to write a plus b whole power 5. A plus b whole power 5 can be written as with the help of this. These are 5c0 a power 5 plus 5c1 a power 4, power a decreases, power b increases. 5c2 a cube b square plus 5c3 a square b cube plus 5c4 ab power 4 plus 5c5 is b power 5. This is in this way we can expand whatever the index given. Now I am writing actual statement for binomial theorem. Now we are writing binomial theorem for integral index. If n is positive integer and x comma a are real numbers, then x plus a whole power n equals to nc0 x power n plus nc1 x power n minus 1 into a power 1 plus nc2 x power n minus 2 into a square plus so on. ncr x power n minus r a power r plus so on. Last ncn a power n. This is complete statement of binomial theorem. See here n is positive integer means like natural numbers. N is belongs to natural numbers, remember. N belongs to natural numbers. Next, observe this series, right hand side complete. NC0, here index is n, that's why we are writing these are NC0 to NCN last. NC0 starting, NCN last. Next, first term x, second term a. Power of the first term here, first start with n. Power of the first term is decreasing, see, x power n, x power n minus 1, n minus 2, so on last x power 0 here. That means power of x decreases and power of a is increases. Here a power 0, but not there, a power 0 is 1. Here a power 1, a square, so on, a power r, and last a power n. And one more important point you can observe here. Sum of the indices of each and every term n minus 1 plus 1 will be equals to index n minus 1 plus 1. Next n minus 2 plus 2 is equals to index of the binomial expression. See, n minus r plus r equals to n. This is n. I'm going to write all properties of binomial theorem. See, remember these are the notes. Note number 1. N is called index of the binomial expansion here. Next, second note. Number of terms in the expansion of x plus a whole power n is n plus 1. Why n plus 1 terms here? Because this is first term, this is second term, this is third term, and so on. This is n plus 1. Why n plus 1 here? Already nc0 is first term. How many terms are there total here? 1, 2. nc1 to ncn means number of terms are n. If you include first term, total number of terms are n plus 1. This is n plus 1th term. Next, third note. Here nc0, nc1, nc2, so on, ncr, comma, ncn are called binomial coefficients. These are all known as binomial coefficients. nc0, nc1, nc2, so on, ncr, ncn are known as binomial coefficients. These are the coefficients which are present in binomial expansions. That's why these are known as binomial coefficients. Next, very important note we are going to write. Note number 4. R plus 1th term. Tr plus 1 equal to ncr x power n minus r a power r is known as general term. See, observe this expansion once again. This term is known as general term. Why general term? Every term is in this model only. ncr x power n minus r, difference of n and r. X power is always, see in this nc2 x power n minus 2. X power always difference of n and 2. Here x power is n minus 1 means difference of n and 1. And this one will be present here. A power 1, 2, a square, r, a power r, n, a power n. That means every term is in this model ncr x power n minus r a power r. That's why this term is known as general term. So this is called r plus 1th term. Why? Because suffix is 0 but this is first term. Here nc1 suffix is 1 but this is second term. That means 1 is there, 1 plus 1, 2. Here suffix is 2 but third term. This is number of terms if you count 1, 2, 3 and so on. What about this term here? Suffix r. That's why this term is known as r plus 1th term. And so on. This is already n plus 1th term, last term. So this term r plus 1th term is called general term. Note number 5 is the binomial coefficients which are equidistant from beginning and end are equal. With the help of the example, you can understand this statement. For example, I am taking a plus b whole cube. A cube plus 3a square b plus 3ab square plus b cube. What are the coefficients? Just I am writing only coefficients here. 1, 3, 3, 1. Here observe this. First and last coefficients are equal and 3 coefficients are equal. So therefore, beginning and end equidistance means this is one is a first term from the beginning, this one is last term from the beginning. Similarly, this 3 is second term from the beginning, this 3 is second term from the last, both are equal. Similarly, third term from the beginning, third term from the last, always equal. So this concept we can extend this statement. That means first and last means nc0 equals to ncn. This is first binomial coefficient, last binomial coefficient. Similarly, second binomial coefficient here nc1. In this second from last is NC n minus 1. N previous number is n minus 1. So these are equal and so on. Why? Because one of the formula is there, we have NCR is equals to always NCn minus R from permutations and combinations. Therefore, binomial coefficients which are beginning and equidistance from the beginning and last are always equal. This is note number 5. Note number 6 here. R plus 1th term TR plus 1 in x plus a whole power n is not equals to TR plus 1 in a plus x whole power n. These are not equal. Why? You know already this is, what is this in this expansion? This is R plus 1th term. R plus 1th term in the expansion what? X plus a whole power n. TR plus 1. TR plus 1 in x plus a whole power n equals to NCR x power n minus R a power R. But TR plus 1 in a plus x whole power n. Just interchange x plus a plus x substitute here. Remaining as it is NCR a power n minus R. This is x power R. These two are not equal. That means even though x plus a whole power n, a plus x whole power n both are same, but their corresponding terms are not equal. That means T1 in x plus a whole power n is not equal to T1 in a plus x whole power n. X plus a plus x both are equal, but in their expansions corresponding terms are, respective terms are not equal. We have to solve one of the problem using binomial theorem. Expand 4x plus 5y whole power 7 using binomial theorem. With the help of binomial theorem, we can expand this. 4x plus 5y whole power 7 equals to 7c0. Binomial coefficients, we have to start with 7c0 to last to 7c7. 7c0 4x power 7 plus 7c1 4x power 7 minus 1 6 into 5y whole power 1. 7c2 4x 7 minus 2 5 into 5y whole square plus 7c3 4x whole power 7 minus 3 4 5y whole power 3. 7c4 4x whole power 7 minus 4 3 into 5y whole power 4. 7c5 4x whole power 7 minus 5 2. 5y whole power 5. 7c6 4x whole power 7 minus 6 1. 5y whole power 6. Last 7c7 4x whole power 7 minus 7 0, need not write. Last 5y whole power 7. This is binomial expansion. That's all. How many terms? Total number of terms are 8. This is by using binomial theorem. Expansion means we are getting 7c0 to 7c7. First power decreasing. Power of the first term is decreasing. Power of the second term is increasing. 7, 6, 5, 4, 3, 2, 1, 0. First power decreasing. Power of the second term 0, 1, 2, 3, 4, 5, 6, 7 increase. This is using binomial theorem expansion. Take another example. Find sixth term in the expansion of 2x by 3 plus dy by 2 whole power 9. Directly we have to find sixth term from this. Actually index is 9 means here we will have total 10 terms. If we expand this theorem, we will get 10 terms. But here required, sixth term only required. By using general term formula, we can find out sixth term. Solution, given expansion 2x by 3 plus 3y by 2 whole power 9. Comparing with x plus a whole power n. Now n is 9 here. X is first term 2x by 3. A is second term 3y by 2. General term formula. General term GT. TR plus 1 equal to NCR x power n minus r. A power r. Here required value sixth term. So T6. In the form of r plus 1. This will be T5 plus 1. 6 can be written as 5 plus 1. Now it is in the form of r plus 1. Now r equal to 5. NCR. N is here how much? 9. 9CR means 5. So x power n minus r. X means first term. 2x by 3 whole power 9 minus 5. 4. Into a power r. A means 3y by 2 whole power r. R is here 5. This is sixth term of the binomial expansion directly by using general term.